while doing operating point calculations. Okay. Just like for a diode, we assume that VB on is 0.7 volts. What this means is, I mean, it's not that we assume a characteristic of this sort. We could do that also. Okay. If we do this, it becomes too much of an oversimplification. Okay. Then the slope of IC versus VB will become infinite here. Okay. So, that is like rather too crude. So, that is not what we assume. We just although it looks like that, what we are assuming is somehow the IS has been adjusted such that you get 0.7 volts for every transistor in any problem. Okay. That is the idea. This is so that you do not have to calculate anything involving exponentials. Okay. And this again should be familiar to you from solving diode problems, right. So, this means that you actually calculate IC by assuming the transistor is on, just like with the diode, and then see if you come up with some contradiction or something. Okay. And this VC sat being VB on, what it means is that, so here we will have 0.7 volts and here this should be greater than 0.7 volts. Okay. So, if I look at this voltage, what can you say? VBC, it should be negative. Okay. VBC should be negative. So, again I think you know the structure of the bipolar transistor already. This is the, maybe I will draw it in the same way. This is the collector, this is the base, this is the emitter. So, you apply some VBE, it will be about 0.7 volts. So, that means that this junction, the base emitter junction is forward biased, right. If you have a PN junction and if you apply a positive voltage to P with respect to N, that is forward biased. And we are saying that VBC, this is less than 0. So, that means that the collector base junction is reverse biased. Okay. So, again this must be familiar from the devices course. This is how you use a bipolar transistor. Okay. So, you forward bias the base emitter junction, you reverse bias the collector base junction, right. What is this device? You just have P and N, diode. This is a diode, right. Okay. So, this is equivalent to right, just connect it up. So, this is the same as having two diodes, collector, base, emitter. Is this correct? Yeah? Why not? Huh? Yeah. So, the difference between this is that difference between having two separate diodes and the actual bipolar transistor is that the width of this region is very, very small. Okay. So, that width is what gives you the transistor action. So, you forward bias this. Okay. So, the current flows here, I mean the current flows here, but because this is so narrow, all of it gets fired into the collector and comes out as collector current. That is what gives you amplification, right. So, if it was if this region was very wide, all this current would simply go into the base and you would not get any amplifying action. Okay.